This is a continuation of the Geometry Semester 2 final review. On the first problem, 12, what is h to the nearest 100th? To the nearest hundredth. So what they've given me is an angle and two sides. So if I look at this angle, I know that h is my opposite, and I know that 120 across from the right angle is my hypotenuse. So remember that sine is the opposite over the hypotenuse. So I'm going to use sine here and say sine of 55 equals h over 120. Then I'm going to put that as a proportion and cross multiply, and I'm going to get that h is, it says hundredth. And I have rounded to tenths. So I'm going to fix this real quick. This is going to be 98.30 feet. There you go. True or false? All parallelograms are quadrilaterals. That is indeed true. The diagonals of a parallelogram always bisect each other. A major arc of circle P is, well, there's multiple answers you could have here, but remember a major arc is greater than 180, and it's you use three letters, the two end points of the arc on the circle and one other point on the circle. So I'm going to draw this arc from H to F, and I'm going to name it major arc HEF. Sorry, my phone or my clock is going off, so you're just going to enjoy the music here. Okay, another one you could do is from H to E. Again, that's over 180, and I could call this major arc EFH. Give at least three characteristics of a kite. Okay, one is that two pair of consecutive congruent sides. A kite always has two pair of consecutive congruent sides. Another one is that a kite has one set of opposite angles that are congruent. And a last one is that a kite's diagonals are perpendicular. Given segment AC bisects segment BD, so let's look at this. Segment AC, which is right here, bisects segment BD, which is right here. What can you conclude about segment AC? Well, notice it says the word bisect, and also notice in my diagram that it not only intersects it, but it intersects it at a right angle. So it is a perpendicular bisector. And anytime you have two chords, one of which is a perpendicular bisector of another, the first one is a diameter. So I can say that segment AC is a diameter of that circle. Given circle O and the measure of angle B is 62 degrees, then find the measure of angle POQ. Now let's just draw in angle POQ. Okay, notice since the vertex is at the center of the circle, that is a central angle. Now remember that when you have an angle that touches, the vertex touches the side of the circle, that is called an inscribed angle, and an inscribed angle is always 1/2 the measure of its intercepted arc. So if angle R is 62 degrees, that intercepted arc is 124. It's twice 62. And also remember that the measure of an arc equals the measure of its central angle. So if that intercepted arc is 124, then that central angle, POQ, is also 124 degrees. Write the standard equation of a circle with its center at the origin and radius of 8. All right. Well, the first thing that we would do is take our standard equation of a circle, and we would say x minus 0, because the origin is 0, squared, plus y minus 0, because again, origin squared, equals the radius squared. But we're never going to write it like this. We're always going to simplify, and we're going to say x squared plus y squared equals 64. And that's one way you can tell that this circle is at the center, as at the origin. Write the standard equation of a circle with a center -5, 2 and a radius of 10. Well, the first thing I'm going to do is take my x value and put it in my standard equation. Notice that since it's -5, it's going to change it to x plus 5 squared, plus then I'm going to put in my y value as y minus 2 squared equals the radius squared. But again, I'm going to simplify this, and I'm going to say x plus 5 squared plus y minus 2 squared equals 100. Calculate the volume of the cone. Well, recall that the volume formula for a cone is 1/3 pi r times the pi r squared, times height of the cone. And so now I'm just going to plug in numbers. I'm going to say 1/3 times pi times 5 squared times 9. And I get that is 75 pi. If they wanted me to change that to decimal, that would be 235.62 inches cubed. Now, find the volume of the pyramid shown below. Well, recall that volume of a pyramid is, sorry, I needed to fix that because it was not base times height. It's 1/3 the area of the base of the pyramid times the height of the pyramid. Now, since this base of this particular pyramid is a rectangle, this is going to be volume equals 1/3 times length times width times height of the pyramid. So now we're just going to put in some numbers and put it in our calculator, and I get that the volume of this pyramid is 112 inches cubed. Remember, volume is cubed, area is squared. What is the surface area of a sphere with a radius of 5.4 feet? Well, recall that surface area for a sphere is 4 pi r squared, and then just put in the 5.4 squared, and I get that the surface area of this sphere is 366.44 feet squared. Find the measure of each exterior angle of a regular hexagon. Well, I'm talking about an exterior angle and a hexagon. Sorry about that. A hexagon, which is a 6-sided figure. So remember, to find the exterior angle, you take 360 divided by the number of sides, and I get that each exterior angle of a regular hexagon is 60 degrees. The last problem is, what is the area of a rhombus? We'll recall that the formula for area of a rhombus is 1/2 times diagonal 1 times diagonal 2. On this particular rhombus, since a rhombus is a parallelogram, its diagonals bisect each other. So if 1/2 is 16, the other half has to be 16. Also know that a rhombus, its diagonals are perpendicular. So I have a right angle there, which makes that a 45, 45, 90 right triangle, which means both legs of that right triangle are 16. So to find the diagonals here, this diagonal is 16 plus 16, which is 32, and the second diagonal is 16 plus 16, which is 32, which also makes this a square. So I'm going to put those diagonals into my formula, and I'm going to get that this rhombus has an area of 512 centimeters squared.